Hello everyone. Today I'm going to actually explain this question. The LeetCode number is 1879. The minimum XOR sum of two array. Okay, so in this array we can say we are given two integer array numbers 1 and numbers 2. The length is the same, is n. So we can see from here the constraints here. N equals to, so the length is the same, and also the length smaller than 1 and greater than equals to 1, smaller than 14. This is the constraints. So for this question, we are trying to actually find the XOR sum of the two integer array. So for this question, the XOR sum of a two integer array, actually, it is what we do is for each corresponding index, we do XOR for those two numbers, like for those numbers two, the two numbers, and then we summarize everything together. And then also we can see here, we can rearrange the elements of numbers 2. So in this way, we can got the minimized sum of the XOR sum. Okay, so this is kind of the problem. So let's pay attention about the constraints here. N greater and equals to 1, but smaller than 14. So keeping this in mind, whenever you saw this number smaller like this, and then we can try using the bit mask. Yeah, which means we can use, in this problem, we can use dp plus bit mask, like the bit manipulation technical to solve this problem. We can use the bitmap to represent each number and with some state. So since we can, we're given the numbers 1, and then we can rearrange of the numbers 2. That means for each element, we can do XOR with any number of the numbers 2, with any number of the numbers 2. So that means we can see we cannot do greedy approaches to solve this problem, because the numbers 2 can be rearranged. So yeah, so that's why we cannot do the greedy approach to solve this problem. From this problem, let's give this input example. So let's see this example here. We give numbers 1 is equals to is 1 2, numbers 2 is 2 3. So when we use the bmap to represent, so it's gonna be 0 1 is this one, and 1 0 is 2, and then the second array 2 here is 1 0 1 1 represent 3, this element. So this array 1, array 2. So when we do XOR, the result it will be so this one is different, same, different. So the result will be when different is 1, when same is 0. So here it should be like this. Okay, so and then we plus this 2, and then it equals to 1 1 equals to 3 plus 1 equals to 4. So yeah, and then this one, let's see, here is a 1, 0, let's plus 0, 0. So so this one is gonna be 2 plus 0 equals to 2. So so basically so let's see here, this is the numbers 1, and the numbers 2, the order of numbers 2 here is 2, 3, but we also can rearrange the numbers 2 become 3, 2. So this example here is a 3, here is a 2. So the first element in array 1 plus I mean like x or the first element in array 2 equals to this one, and then we got the sum of this order is 4. But if we rearrange the numbers 2, let's see, we got 2. So compare 4 and 2. The minimize XOR sum, it should be 2. This is the answer. Yes, this is the answer. Okay, let's say if we do have the state, let's say if we do have a state equals to 1 1, let's say this. Okay, okay, so that means that both the zeros and the ones elements are in the state. Here we go. We have the example of this one, the numbers 2. So numbers 2, we use this. So we only have 2 digits. So the state, if is 1 1, then both the zeros, the index 0 and the index 1, the elements are in the state because both are 1. So let's say another one. So if current state equals to, let's say, 110, and now we got I equals to, we use this method count bit state equals 2 because we have 2 ones in the current state. It's already in the state. That means that we have 2 elements in numbers 2 already matched. So the I equals to current beta state. We have 2 1, so that's why here is 2, and that's already matched the first 2 elements in numbers 1. So that means that the first 2 element in the first 2 element in numbers 1 already matched because the count we have 2. So that's 0 and 1 is already matched here. So yeah. Let's see here, the DP state. So what does that mean, the DP state? The DP state, like the state 110, if 110 is here. So the DP state, we are looking for like is represent the minimum XOR sum for all base element in the state. So means that DP state will get the minimize XOR sum for all the numbers 2 element in the state. Okay, so the DP next means that we're gonna get one more element in from the numbers 2 to the state. So let's say the dp next will equals to dp state plus numbers I XOR numbers j. So that means from numbers 1, here is numbers 1 I, numbers 2 j. Okay, from numbers 1i to numbers 2j, get that one plus 2 here. So, and then this is next dp. Okay, so in this question, we can see the input of this problem is numbers 1, numbers 2, their array, and then we return a integer. We return a int here. So first, we are going to actually start from here. We do int n equals to numbers 1 length, okay, and m equals to 1 left shift m. Okay, so here let's explain this way. So here if n equals to 2m, if we do this shift 2, that means actually from a 1 0 1 0 0, this one is from 0 to 4 minus 1. That means we actually iterate. Let's do 1 0 2 3. Okay, this one actually is this one actually is 2 to the power of 1, 2 to the power of n in this question, in here, in this. And then what we're gonna do, we're gonna do this. dp equals to new int n. Okay, so for here we can see the dp, the dp 1111, let's say 11. So if dp 111 means all elements in numbers 2 are selected. Okay, that means are selected. Okay, so because let's say n equals 2 and m, we actually m equals to this one, 1 left shift 2 digit. So it will become 0 1 0 0. This one means m will equals to this one. This one means from this one here, we have m, right? So that means the dp, the size is m. So means from 0 to 4 minus 1 is 3, is 0 1 2 3 are selected. So yeah, so like a dp 0 means we only select the index is 0 from the numbers 2, and then m equals to 1, we select 1, select 2, select 3, yeah, something like that. And then dp 1111 means all elements in numbers 2 are selected. Okay, let's initialize this. dp 0 equals to 0. Okay, so let's start the dp 0 equals to 0, and then we iterate for integer state equals to 0 and the state smaller than m. That means the state we start from the state we have example. Yeah, the state we start from 0 to 4, like a state 0, state 1, state 2, state 3. So state from 0, and if n equals 2, that means this, and from there. Okay, so state, let's do this. Okay, let's do I equals to integer the bit count state. And then let's continue coding. So so we're here, and then what are we gonna do if I smaller than n, and then we do for integer j equals to 0, j small n, j plus plus. Okay, so first we need to check each element in the numbers 1, because numbers 1 is 2. We can also do 3. So yeah. So and then we check from 0 to n minus 1. So each element in numbers 1. So and then here we iterate each element from numbers b. So for this one, what we do, if we do this, if this one equals to 0, then what are we going to do? Okay, let me explain this part. State with this one. So let's give an example. Let's give an example. Let's give an example. N equals to 3. Okay, let's give n equals to 3. In this case, the this number is 1, right? So and then we do j equals to 0. We can also do j equals to 1, j equals to 2, j equals to 0, j equals to 1, 2. Okay, here is 1, here is 2. So that means, let's give an example of 0101. Okay, so 0101 with this one, and this one is 1 minus this one. Okay, this one equals to 1. So the reason is that see, we can see here the first index of this state is 1. When 1 and 1, so 1 with 1, because it's all 1, so it equals 1. That means the first one is are matched. This one are matched. And then when we do the j is 2, this no, sorry about that, j equals to 1, j equals to 1 is this one. So and then what do we do? Let's just copy paste. So when we do here, we actually shift one digit. Shift one digit is here, and this one is equals to 0. This one equal to 0. Oh, sorry about that. So this one equals to 0. That means we are trying to get 0. That means this one is not matched. Here we have to know this. We have to know the 1 more than left shift 1. This one is going to equals to 0, 1, 1, 1. Okay, so this one have extra. We need extra to put in the names 1. Oh, numbers I. Here is I, and the numbers and the name J. So yeah, this is basically the meaning of this. Okay, let's do if j equals to 2, this is 0, 1, 2 equals to 2. So it's gonna be yeah, shift 1. Okay, so this one we're gonna do now. This one equals to 1. Yeah, this one equals to 1. So that means we will skip. So it's talking about here. Okay, so it's gonna be, let's do this. Int next. This is the next stay or and then dp max equals to max dot and then we return. So the dp next, actually we are looking for the minimize dp next, and this one is dp current state plus oh sorry, it's not a, it's names 1 and the numbers 2. Yeah, it's numbers 1 and the numbers 2. Yeah, and then we return after the 4. Yeah, and then we return dp m minus 1. Let's run the code. Okay, here we need to change something here. Here, okay. Yeah, because we need to actually put this arrays dot fill the we need to initialize this. Okay, integer the max. Oh, max. Oh, max value. Okay. Okay, here actually we do yo here, yeah. So, yeah, because in this line, in this line we have addition here. So, that's why we need to shift one bit. Okay, yeah, it's accept. Let's yeah. So let's talk about the time complexity for this question. So, the time complexity for this problem. So yeah, from here we can see here, we can see here, here is m, and then here is n, and then also we have we did the dp. So the time complexity will be O minus n, no, not minus n, by 2 to the power of n. Okay, this one actually, because here n equals to 14, so 1000 plus 14, and no, plus, sorry about that, multiply. Yeah, so it's gonna be this. Yeah, it's gonna be this. This is okay. The time complexity gonna be O n, and this one, so it's gonna be this. And then the time complexity, no, the space will be 2 power n. Okay, because we use dynamic programming, so the space complexity is big O, 2 to the power of n. Okay, this is a problem of uh, uh, the LeetCode number 1879, minimum XOR sum of two array. Thank you for watching. Let me know if you have any question. Okay, let's try this. Let's try the submit. Okay, it works. Success. Okay, so the runtime is 12 ms, faster than this much. Okay, thank you. Thank you for watching.